Hello! This week in our videos we'll be looking at trigonometric functions. We're going to start off with a concept that I'm sure you're familiar with, the Pythagorean Theorem. Now, of course, the Pythagorean Theorem is only valid for right-angled triangles, so we can only use it some of the time, but it sure is useful when we can use it. So if we have a right-angled triangle, and it has side lengths A, B, and C, then we have this wonderful formula here. The square of this, the two sides A and B added together gives us the square of the length of the hypotenuse. So we can solve this to, or use this to solve fairly straightforward problems. Like for instance, let's say we have a right angle triangle and we have a hypotenuse of length 13 and a side of length 5, and we want to find the other missing side. I don't know, let's call it x. Then we'd have x squared plus 5 squared is equal to 13 squared, and we just need to calculate all of this. Of course, when I square root both sides, I should be considering the positive or negative square root. But, of course, since we're actually talking about a side length, we'll only keep the positive value. Let's try a few more examples here. So here, we can find all of the angles and all of the side lengths. We'll use the Pythagorean theorem, but we'll also use our trig ratios as well. So we'll kind of be putting those two ideas together. Of course, we can use both of them when we're talking about right-angled triangles. So the first thing we'll do is draw a picture. I know I have an interior angle of size pi by 6, and it says here the opposite side has length 3. That's that one there. Well, I know that all the angles inside my right angle triangle have to add up to pi radians. So if I take pi and I subtract pi by 6, and I subtract, it's a right angle, that'd be pi by 2, well, our common denominator here is 6. And we're left with 2 pi by 6, which of course I won't stop there. As always, we'll put it in lowest terms. So that tells me the measure of the missing angle up there, pi by 3. Now, we should be able to figure out what our different side lengths are. So, for instance, let's say I want to find the side length of, I don't know, let's call this the hypotenuse, and that x. If I want to find, let's say, the hypotenuse, I could use just a trig ratio. I could say the sine of pi by 6 would be equal to the opposite side, which has length 3, over the hypotenuse, which we don't know, but we're calling h for right now. Now the sine of pi by 6, if you try it out in a calculator, you'll find out that it's a half. And so we get this simple equation for h, and I can solve it and find out very quickly that h is 6. Okay? And then I can use the Pythagorean theorem, since I have a right angle triangle, to say, so by the Pythagorean theorem, we now know two sides. We could have x squared plus 3 squared is equal to 6 squared. So we have x squared plus 9 is equal to 36. X squared is equal to 27. And that means that x is equal to the square root of 27. And if we want to put that in lowest terms, we could write that as x being equal to 3 root 3. Okay, so we can use our trig ratios, since they're valid, SOHCAHTOA is valid for any right angle triangle, right with the Pythagorean theorem to find both angles and side lengths. Let's try another example here. All right, this time we have an interior angle that's pi by 4. The hypotenuse has length 5. Again, we can take pi minus pi by 4 minus pi by 2, the value of that right angle, put it all over a common denominator. And interestingly enough, we're left with 1 pi by 4. So what does that mean about our triangle here? Well, since we have two angles that are identical, that means that we have an isosceles triangle. That means that whatever the length of this side is, it's the same as the length of that side there. So let's give names to these two sides, and I might as well use the same values since we know they're the same length. We can straight up use the Pythagorean theorem to figure this out. So we have x squared plus x squared is equal to 5 squared. So 2x squared is equal to 25. X squared is equal to 25 over 2. And then we can square root both sides, and we get that x is equal to the square root of 25 over 2, which if I simplify that, I get 5 over the root of 2. And if you want to be really polite, we can rationalize that denominator, multiplying top and bottom by root 2, and we get that x is equal to 5 root 2 over 2. So there we go. So again, you can use the Pythagorean theorem. I'm sure you're very familiar with it whenever you have a right angle triangle. And we saw in these examples, of course, that's also the situation you can use SOHCAHTOA. Thank you.